we're really not going to spend too much time in section 8.6, but really what you need to know is this theorem, which actually comes out of the fundamental theorem of algebra, saying that any polynomial equation with complex coefficients, right, even whole numbers are considered complex number because the number multiplied by I would be 0, and any positive degree n has exactly n roots. And if you look at this table, you should see that. Degree of 1, 1 root. Degree of 2, 2 roots. Even though those are complex roots, they are still roots. Degree of 3, 3 roots. Degree of 4, 4 roots. Degree of 5, 5 roots. Some of these are real, some are imaginary, but either way, this theorem does hold true. Now, in your notes, you should have read the rational root theorem. And what that says is that h over k will be a root where they're relatively prime integers, but h needs to be a factor of the constant, and k must be a factor of the coefficient of the leading term. So here's what we're going to do. This is actually easier to show you than to try to explain it to you. So the rational roots will be h over k. So I list out all the things that h could be. Well, I need factors of -1. That's actually pretty easy. Plus or minus 1. Do the same thing with k. But now I need factors of 4. Well, plus or minus 1, plus or minus 2, plus or minus 4. Our possible factors are h over k. So what that is, plus or minus 1 over 1, plus or minus 1 over 2, plus or minus 1 over 4. These are the possible rational roots. Let's take a look at the next one. So I'm looking for h over k. H, I'm dealing with this -3. So that's plus or minus 1 and plus or minus 3. For k, I need the 6. 1, 2, 3, and 6. So now when I'm listing out those roots, I have 1 over 1, 3 over 1, 1 over 2, 3 over 2, 1 over 3, 3 over 3, which we don't write because 3 over 3 is 1, and that's already there. We've got 1 over 6, and then we won't write 3 over 6 because 3 over 6 is a half. So this is the list of all the possible rational roots. They're not exact, remember, they're the possibilities. We'll take a look at the last one. H will be factors of -9. So we have 1, 3, and 9. K will be factors of 2. So h over k, 1, 3, 9. 1 half, 3 halves, 9 halves. So all I've done, 1 over 1, 3 over 1, 9 over 1, 1 over 2, 3 over 2, 9 over 2. Now that we know the possible roots, we need to check and see which ones are actual roots. it doesn't matter what you start with. I tend to start with plus or minus 1, and usually, really, I start with 1. And I do my synthetic division. Okay, 1 is not a possibility. Try negative 1. Nope, negative 1 isn't a possibility either. Try 1/2. We have a winner. 1/2 is a root. What we're left with now is this equation, 4x cubed plus 2x squared plus 4x plus 2. So we need to find the rest of these roots. So let's take a look at the rest of them. In order to do that, we actually continue this process. So we'll say, okay, well, I've already used plus or minus 1. I've used positive 1/2. So let's use negative 1/2. And now we're going to use the depressed equation here. So we know that negative 1/2 is also a root. And we're left with 4x squared plus 4 is equal to 0. Now that we've got it down to a quadratic, we can find the remaining roots. So my 4 roots are 1/2, negative 1/2, I, and negative I. So here's our next problem with the list of possible rational roots. And again, we're going to just systematically go through our synthetic division until we find something that works. This is going to give me 4, so 1 doesn't work. Again, I can stop right here because I see the remainder will not be 0. Negative 1 doesn't work. I can actually stop here because I know 71 times 3 is not going to give me positive 3. So stop there. Again, I can stop here because I can see that 23 times negative 3 will not give me positive 3. One half doesn't work. -1/2 doesn't work. So this problem actually gets to be continued. As you can see, I've crossed out the ones I've already used. I've only got 6 more to go. So next we try 3/2. Again, I can see if I multiply these two, I will not get +3 as an answer. So I can just eliminate 3/2. And then again, 11/2 times 3/2 is not going to give me +3. So we'll keep going with +1/3. Let's try -1/3. Oh my good gracious, that one works. So now we're left with 6x² plus 6x minus 9. Set that equal to 0. We can factor out a 3. Once we get to this point, we need to find factors of this, and unfortunately, it's not awesome. The only rational factor we have is this one. The rest of the factors are in fact irrational, and if you use quadratic formula, you would find that they're -1 plus the square root of 7 over 2, and -1 minus the square root of 7 over 2. So those are your 3 roots. 1, 2, 3. This is the only one that's rational. So now that you've seen this method of using synthetic division for the whole thing, now I'm going to help you eliminate 2 roots right off the bat. And the 2 roots I'm going to help you eliminate are plus and minus 1. Because remember, if it's a root and we plug it into the equation, we'll actually get 0. So if you use +1, you get 2 plus 3 minus 7 plus 3 minus 9. And we need to see if that's equal to 0. It's equal to -8. So we know +1's not a root. We can do the same thing with -1. We'll get 2 minus 3 minus 7 minus 3 minus 9. And for that we get -20. If you're wondering why I said -3 here and +2 here, remember -1 to the 4th is +1. So that's here. -1 cubed is -1, so that's why I have a negative. -1 squared is +1, so this one stays the same. -1 just by itself is negative, so 3 times -1 is -3. Now that we've done that, let's start with 3. Boy, that sure made that process a little easier, didn't it? Okay, we should be able to see right off the bat here, this is not a root. Let's try negative 3. Oh, looks like negative 3 is a root. So now we have 2x cubed minus 3x squared plus 2x minus 3. So we do have to keep going with each one of these values. Although what we can look at is the possible roots for this depressed equation, right? So we have h over k here. We've got h is equal to plus or minus 1 and plus or minus 3. K would be equal to plus or minus 1 plus or minus 2. So we're looking at 1, 3, 1/2, 3/2. Oh, Miss Busselmeyer, I'm so glad I watched the end of this video. Now, I already know that plus and minus 1 don't work. I already know that positive 3 doesn't work. Negative 3 could be a double root, so we do need to consider that in addition to the rest of the ones that we're looking at. So we would start with negative 3. Yeah, that's not going to work. Let's try 1/2. One-half doesn't work. I'm going to stop here. You have 3 more to try. Try them on your own and finish this problem.